Okay, we're going to have a look at what's known as free surface effects. Free surface effect is when you have slack tanks on a vessel. In other words, the liquid, the fluid inside the tank isn't pressed up. It's not filled up to its maximum. And if we look at the sketch here, what actually happens when the vessel sails out to sea? She's inclined by an external force and heels over. Obviously, when the vessel's in port and she's upright and not moving, the tanks don't necessarily cause a problem. But when the vessel sails out to sea and we get this external force, the vessel will heel over to one side. And what happens is the volume of liquid moves over to the lower side. And as we can see from the sketch here, this volume of liquid moves over to this side. And the centroids of the two volumes are marked small g to g1. Therefore, the distance the volume has moved transversely is that distance there. And what it does, as the vessel is heeling from side to side, it causes a continuous movement of large G, the vessel's centre of gravity. How this impacts upon the vessel is that as G moves to G1 towards that volume of liquid that's moved over, it effectively reduces the righting lever. So before, if this water hadn't been slack here, this liquid, our righting lever would have been G to Z, GZ, the large amount, and therefore the righting lever would have acted accordingly and created the torque to bring the vessel back upright. And the definition of a righting lever is the perpendicular distance between the buoyancy force acting straight up and the weight or gravity force acting straight down. So we can see here that because that's so, GZ must move up to G1, GVZV, because it has to fit between the weight force and the buoyancy force. Therefore, this is what we call a real loss. So the righting lever, the loss of the righting lever that we suffer is definitely very real. G, of course, then moves to GV, and G to GV represents a virtual or apparent loss of RGM. And we can see that this value, this free surface correction or free surface effect, reduces temporarily the GM of the vessel. So in other words, the GM becomes a fluid value. When the vessel rolls back or goes back and she's upright, then of course G will maintain its normal position. When she goes over, we'll have the virtual loss again. So this is known as a virtual or apparent loss, but the GZ, you have to realise, is a definite real loss. So in other words, the ability of the vessel to right herself is compromised because the GZ, the value of GZ, is reduced, but GM is an apparent loss.